Okay. In the previous class, we discussed about version space search. Okay, version space search, and we discussed the different methods. Okay, which are the different methods, Anusri? Which are the different version space search methods? So what is the use of concept learning? What is meant by concept learning? We discussed it. Then about the different methods of version space search. Okay. So basically, if you understand the concept, we use version space search. There are three methods: specific to general search, general to specific search, then candidate elimination algorithm. There are three methods. Okay. There are three methods. Okay. Then okay. So after that, we discussed about the version space of a problem. So before that, what is version space search approach, Vishnu? What is version space search approach, Vishnu? What is version search approach? Method is first we create a version space of the problem. Okay, that is the first step. Then after creating the version space, we will search the space using the above algorithms. That is the version space search approach. So that also we discussed. Then in the previous class we discussed how can create the version space. Okay. For example, this is version space of a problem. This is the version space of a problem. How can create this version space? We can use different operators. Okay, which are the different operators? Various generalization operators can be used. Okay, various generalization operators can be used to create a version space. So this is a version space of the one problem. Okay. Then we can consider this figure. Okay. So there are. This is the version space, and this is called the concept space. Okay, concept space and version space. Okay. So two types of approach. One is most general. What is most general hypothesis? The top hypothesis in the version space is called most general hypothesis. It contains only the variables. Okay, it contains only the variables. You can note that. Then we discussed what is most specific. The bottom level is most specific, and the properties contains the values only. Okay. So anyway, in the previous class, then we discussed about this algorithm. One is general to specific search approach. Okay. So in the first part of this algorithm, we will initialize G. G is a variable and P is another variable used in it. G is initialized to the most general concept in the space. Okay. The most general concept in the space. P is initialized to the most general concept in the space. So what is most general concept means? the topmost hypothesis in the version space. Topmost hypothesis in the version space is called the most general hypothesis. Okay, sorry, most general hypothesis. Okay. Okay. Most hypothesis. Then another variable is P. P contains all positive example. P is a variable which hold the positive example. Basically, P is a set. It contains all positive example seen so far. Okay, seen so far. Okay, so initially P should be empty because initially uh, we haven't seen any positive example, so P is empty in this case. Okay, this is the initialization step of this algorithm, and after the initialization step we will execute two parts. First part is for this is the first part, and it is for a negative instance. Okay, when a negative instance is given, then what action should be taken? Okay, and another is the positive case. If a positive instance is given, then what action should take? Okay, so in the negative, now we can move to this part. Okay, this is the first part in this. Okay, so yeah, this is very important. Okay, this is very important step. For E belongs to G that matches N. For E belongs to G that matches N, replace G with its most general specialization. Most general specialization that do not match. This is one action. After performing this step, we will execute two delete steps. This is one delete step. This is another delete step. These two are very simple. You can easily understand. But this is somewhat complicated. Okay. Anyway, now we are going to discuss this concept with an example. Okay. With an example, we are going to discuss this concept. So initially we know G. G is the, you can note here G. Okay. G is what? Initially G is initialized the most general concept. Which is the most general concept here? Object in bracket capital X, capital Y, capital Z. Okay. All are variables. Okay. So this is G is initialized. Okay. And P is initialized to empty. Okay. Then we are giving a negative example. Okay. Note here. We are giving a negative example. That is a negative example is coming. Okay. So what action we should take? First step is we should compare this negative instance to the concepts in the concept space. Only one concept is there. In this case, only one the concept space. Okay. Then we compare this negative instance to this. Okay. If it matches, we should do some other procedures. Okay. Try to understand that. That is, if the negative instance matches with one of the hypothesis in the G, then we should do some procedures. Okay, here first we can check whether it match or not. Okay, here is a negative instance. This is small. This is a variable. Okay, small. Then next is red brick. Okay, red is another property. So red, it is a value here. It is a value of the variable red. Okay, red. Then another value is brick. Okay, brick. It is a value. Okay, not the understand the concept. It is all value. Okay, brick. So we will try to match with what x, comma y, comma z. X, comma y, comma z. So it will match y. It will match y because x is a variable. It can take the value small. Is it okay? X is a variable now and it can take the value small. Okay. So here is small. So it matches. Okay. So okay. This is okay. Next, y is another variable. It can take the value red. Other colors also it can take, but it can take red. So this also matches. Then we consider the third case. Set. Set is a variable. Okay, set is a variable here. Set can take a value, brick, other values. Okay, so here the value is brick. So it is also matches. In this way, we will check whether these two hypotheses match or not. This is a very important concept. Okay, so the way of checking whether a hypothesis match with another hypothesis or not. Okay, so try to understand this concept. Okay, this is very important. Okay, so in this case, what will happen? In this case, I will show here, this negative instance match with the concept in the concept space. Okay, which is that concept actually? Which is the most general hypothesis, object of x, y, z. So it matches. Then what action we should take? Let us go to the algorithm. For each g to g that matches n. Okay, it matches. If there is no match, no need to execute this step. It matches. So what we will do? Okay, it matches. So what we will do? That is okay. So we want to execute this part. Replace G. That is, we want to replace the matched hypothesis in G. Okay. Replace G with its most general specializations that do not match. Okay. That we want to perform here. Replace G with the most general specializations that do not match n. Okay, this is we want to perform. So what its meaning is that, okay, just consider this case. So this is the hypothesis in G. Okay, this is matched with the negative instance. Okay, so this is also very important step. Okay, so try to understand this concept clearly. This is the hypothesis now we are considering. This is matched with the negative instance using this concept. This is matched. Okay, object of exciting. Okay, this is matched. Now what we will do? We want to find out the most general specializations. Okay, it's very important. What is most general specializations? Okay, what is most general specializations of G? Okay, so sorry. These are the most general specialization. That is, you can note here this one. You can note here. These are the 1, 2, 3, 4, 5. These are the different specialization, most general specialization of X, Y, Z. That is, you can note here object or O in bracket, instead of X, what we will do? We will replace X with its value. Okay. That is, we want to find out the most general specializations of O of X comma Y comma Z. Then we will replace one variable with its value. Okay. Then we will get one specialization. Okay. Here, object of white comma X comma Y. This is one specialization. This is one most general specialization of O. This one. Okay. Then what we will do? Another thing is, basic concept is very simple. We will replace one variable with its values. Okay. Okay. So what will be this? What will be this? This is, I'll show here, or this is O of, then X takes the values. Which are the values X taking? X is a variable which takes the value one minute. This is X. Okay. X, Y, Z, and X is basically Harida. I'll ask a question to you. Hello, Harida. Harida. Harida, present the line. Okay, this is one generalization, most general specialization, object of white comma y comma z, which will be the another generalization. Harida, Saurabh, Harida, Harida, which will be the another most specialized generalization, most general specialization. Just we want to replace x with its value. One is I replace the x with white. X takes the value white, red, different colors it will take. So here I replace the x with white. Okay. So white comma y comma z. What will be the next color? Which is the next color x taking? Which is the next color? Red, white, blue are the different colors. Okay. Then Saurabh parne. Saurabh. ഒന്ന് റിപ്ലൈ ചെയ്തേ. Okay. Harida. Okay. Then another one will be this. That is, I am replacing x with red. Okay, red color. Then others are y comma z. Okay, y comma z. Okay, this is another most general specialization of this one. Okay, what will be the another one? What will be the another one? Saurabh, object of white, red, blue are the different color. So what will be the next one? We can replace x with blue. Then y and z remains there. Y comma z. Y comma z. Okay. In this way, by replacing x with its values, I will get how many specializations? Saurabh, by replacing x with its values, I will get how many specialization? Vishnu Varna. Vishnu. Anusri. Anusri. Amrita told it's 3. Okay, it's correct. By replacing x with its values. There are 3 values x taking: red, white, blue. So by replacing x with its values, I will get 3 generalization. Most specialized, most general specialization. So next what we will do? Then we will replace y with its values. Okay, x and z remains there. Then we will replace y, capital Y, with its values. Okay, so then we will get corresponding generalizations. Okay, similarly, next we will replace z with its values. Okay, z with its values. We will replace z with its values, keeping x and y there. Then we will get another most general specializations of all. this one. Okay. In this way, we will get different generalizations. We will get different generalizations. Okay. Try to understand this concept. Okay. So how we will find the most general specializations. Okay. How we will find the most general specialization. Okay. So that we discussed now. Okay, here total how many generalization will be there? Okay, anyway, this is the method of finding the most general specializations. Okay, this is the method of finding the most general specializations. Okay, so now we created a different generalizations. Then what we want to do? You can go to the algorithm. Replace G with its most general specialization that do not match N. Okay. We want to find the most general specialization using this approach. Okay. Then we want to delete. We want to replace G with its most general specialization that do not match N. That is, we want to find out the most general specialization that do not match N. That we want to actually find out. Okay. Here, in this case, you can observe here, these are the different, you can note this here. Okay. Here, different most general specializations are given. One is large comma y comma z. Y and z are the variable, large is a value. Okay. Similarly, next is x comma y comma z. Another is x comma y comma ball. Next is x comma y comma cube. These are the generalizations that do not match with the negative instance. Okay, so these generalization should not match with this negative instance. Okay, so basically we want to find out the generalization that generalization do not match with this negative instance. Okay. For example, I am taking this one, object x comma y comma z. Okay. Show here. Suppose I am taking this case, object, one generalization in this set is x comma y comma z. Okay. X comma y comma, this is one of the generalization. Okay, y comma z, x comma y comma z, x comma y comma z. Then we want to compare it with our negative instance. Which is our negative instance? Object small comma red comma brick. Object small comma red. You can note here it is red color. Okay, red comma brick. Okay, red comma brick. These are the values. Here, here you can note white and red. This will match. Okay, this will match. Why? X is a variable. It can take the values more. So this will match. Here Z also match. Why? Z is a variable. It can take the value small, brick, other shapes. it can also match. But here, the white and red is here. These are specific values. It will not match. Okay, white and red here, so it will not match. So this case will true. Okay, this generalization will not match with the negative instance. Similarly, this generalization should not match with negative instance. That property should be satisfied. That property should be satisfied. In this way, we will perform this step. Okay. So basically, I'm just repeating the step. If a negative instance is given, we will try to compare it with the most generalizations in the G. Here it matches. Okay. Then we will generate this special most general specialization. The property should be that it should not match with the negative instance. So this is the way of finding the most general specializations, replacing a variable with its values. It's to find the most general specialization, we will replace these variables with its values, one of its variable with its values. In this way, we can find out the most general specialization. Anyway, we generated this concept space. Then the next step is delete. Delete from G all hypotheses more specific than some other hypothesis in G. That is the next step. That is, after generating the hypothesis, this one, we want to delete it. Okay, we want to delete hypothesis that is more specific than some other hypothesis in G. This is another step in it. Okay. After that, we want to delete from G all hypotheses that fail to match some positive example in P. That is another. We want to perform all these steps. Okay. After doing, you will get a space like this. Then a positive example is given. Okay. So when a positive example is given, what step we need to proceed? This is a simple concept. When a positive instance is given, delete from G all hypotheses that fail to match with P. For example, if a positive example is given, then we want to find out the hypothesis that do not match with P. Okay. That is, we want to find generalizations that do not match with P, then we want to delete it. Then these all should match with this space should contain generalization that should match with the positive example. This is the concept. Okay. So there are two cases. One is negative case, then another is positive case. If a positive case, the concept is very simple. We want to delete the general hypothesis from that do not match with the P. If it is a negative instance, we want to do these steps. Next class, we can discuss that case one more time. Okay. Anyway, this is the this approach. Try to understand this concept. Next class we will discuss one more time. Okay. Okay. Anyway, please give your attendance in the chat groups. Okay. Starting from Abhilash. 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 Okay, next. Abhinav, Ansab. 1 minute. Ansab. Okay, Anusri. Okay. Next, Atul Dinesh. Arjun. Atul Dinesh absent ഇടുന്നുണ്ട്. Arjun. Arjun absent ആ. Atul Dinesh absent. Arjun absent. Okay. Ashwin P. Satyapan. Okay. Ashwin P. Atul Dinesh. Next. Okay. Please give it in the chat box, Satyapan. Be good boy. This one. Caps lock is on, yeah?
ഹലോ മധു സാറേ, അർജുന പ്രസന്റ് ആണ്.
ഹലോ
ഞാൻ പ്രസന്റ് ആണ്.
ഓക്കെ, ഞാനത്
ഓക്കെ.
ഹലോ മധു സാറേ. ഹലോ
ജാസിലെ. ഓക്കെ
പ്രസന്റ്.
ഓക്കെ ജാസിൽ. ഓക്കെ. ഓഫാക്കല്ല.